Now, another way to solve this method is using these formulas that we talked about and we showed in class. We know that we have x and y, so we know this and this, or in the next two we know these two. So we can either use this formula and we would have two equations and two unknowns, and the unknowns are r and theta. We could either do that, or we could find the absolute value of r from here, then the angle theta, and then using the coordinate system figure out whether r is positive or not. So I will start with the second method. So I know what my x and y are, and I'm looking for r and theta for the polar coordinate system. Using the first formula, I know that the absolute value of r is going to be the square root of x squared y squared. So I have them, plug them in. So -1 squared plus 2 squared. That gives me square root of 5. That's the absolute value of r for me. And now I'm trying to find theta. So tan theta from that formula here up here. Tan theta is equal to y over x. Therefore, theta is going to be tan inverse of y over x, which is tan inverse of y is 2, x is -1. So this. So I can, for the purposes of the assignment, plug this into a calculator and find an angle, either a negative theta, so maybe -1.1 roughly, or it would be pi minus 1.1 radians. And then, because I don't know the direction of r, what I would do is I'd say, okay, if I'm going with the -1 for my coordinates, and I'm saying my theta is -1.1, then my angle is this way. Probably this much. This is going to be my ray, and this is the positive direction. Remember, I'm going this way. So if my angle is negative, and here, now where is my point P? It's here. This is the origin. So my point is in the negative side of this ray. So r is going to be negative square root of 5. To be sure you got the right coordinates, polar coordinates, let's reverse the whole thing. We have this polar coordinate, and let's turn it into x and y using these two formulas. So my x is going to be r, which is -5 squared cosine of this in radians, and my y is again going to be negative square root of 5 sine of that angle. So if you calculate these, you'll find the values that we found before, -1 and 2. If you want to check the sign, we can go back to the unit circle. And now here, my angle is in the negative direction, so this is going to be my angle. In this case, cosine is positive. And sine is here, so it's negative. Sine is negative. So this is positive multiplied by a negative gives something that is negative, and sine is negative multiplied by another negative gives me a positive, and that is the same thing we have here, negative and positive, so my signs are correct. And that's an example on how to find polar coordinates from Cartesian coordinates. Now you can see if we want to do it the other way around as we did here, we are going to use the first two formulas here up here. So this is for polar to Cartesian. And you understand it, why we use it. When we have a polar coordinate, we have r and we have theta. So it's easy to find x and y based on that. And if we have x and y, it's easier to find r and tan of theta and then find that theta. So if I have Cartesian and I want to turn it to polar, I use these two. Here. Hope that makes you understand this better.